Some real-life problems can be solved with trigonometry, and they can sometimes be simplified into two dimensions. When you're working with a single triangle, you have to decide what's the best course of action, and there's really three tools you can use: SOHCAHTOA, the sine law, or the cosine law. In this example, we're going to solve for an angle, x, and two sides, labeled y and z. For this problem, I'm going to start with angle x. Since I know two angles, I can automatically figure out what x is because all three angles have to add up to 180 degrees. So if I subtract the other two angles from 180, I can find that x is 60 degrees. So now I can move on to finding y. When I look at my triangle, I can see that I know an angle and its opposite side. That means I can use the sine law. So I set up my sine law, isolate for y, and when I plug it into my calculator, I get approximately 6.5 meters for y. So I know x, I know y, now I'm going to solve for z. Now at this point, I could choose to use the cosine law or the sine law. It doesn't really matter. The sine law is generally easier to work with, so I'm just going to use the sine law again. So I'll set up my sine law, isolate for z, and solve. In this case, I get approximately 7.4 meters. So there you have it. I solved for x, y, and z. In this example, I have two triangles that share a side. They have a side in common. When you're solving problems that involve more than one triangle, the best practice is to determine this shared side first, and then you'll have enough information to find all of your unknowns. I'm just going to label this shared side as A, and I'm going to solve for A. If I look at the triangle on the right, I don't have enough information to determine the length of A. So I'm going to start with this triangle. I know two angles and a side. That's enough information to determine the third side. Since this is a right triangle, I can use SOHCAHTOA. So if this 40-degree angle is my reference angle, I know the opposite side, and I want to determine the adjacent side. So I'm looking for the ratio that uses opposite and adjacent. If I look at SOHCAHTOA, tangent uses opposite and adjacent. So that's the ratio I'm going to use. So I'm going to use the tangent of 40 degrees, and it's equal to the opposite side, which in this case is 15 meters, over the adjacent side, which is A. When I rearrange my equation, I get A equal to 15 divided by the tangent of 40. So A is approximately 17.9 meters. Now that I know the length of A, which was my shared side, I have enough information in this triangle to calculate the length of x. If 25 degrees is my reference angle, I now know the opposite side, and I want to find the adjacent side. So remember, opposite and adjacent, I'm still looking at the tangent. So when I solve for x, I'm going to use the tangent of 25 degrees, and it's equal to the opposite side, which in this case is A, over the adjacent side, which in this case is x. I know that A is 17.9, and when I rearrange my equation, I get x is equal to 17.9 divided by the tangent of 25. And when I calculate that, I get x is 38.3 meters. So I solved my problem. So I just showed you two examples of two-dimensional trig problems. You can use the principles that I used here and apply them to real-life situations.